So we have a diagram like that. GJMK. And angle 1 and 2. Alright. And notice we want to see if JG is congruent to MK. That's what we're going to try to figure out. Is GJ the same as MK? That should be the end of our reasoning, the thing we conclude. So let's see what we have to start with. So M is the midpoint of JK. And angle 1 is congruent to angle 2. And that's a given. So this is in a section on isosceles triangles and stuff, so we're probably going to use that. We're probably just going to leave this triangle whole and not make triangles in it. Probably going to do something like that. So angle 1 is congruent to angle 2. We just had that. That was one of our theorems. Remember, if the angles are the same, then the opposite sides are the same. So we know that GJ is congruent to JM. So this is the same as that. But M is the midpoint of JK. Midpoint, remember, that means middle. Halfway, it divides something into 2 equal parts. So this is divided into 2 equal parts. JM is the same as MK. So those are the same. So we know, but the reason, whoops, on this, okay, so we knew angles were the same, so the sides were the same. Now we know that JM is congruent to MK, and that's from definition midpoint. But what do you notice here? Hopefully you notice something being repeated. This goes to here, which goes to there. So this weighs the same as that, but that weighs the same as this. So these weigh the same amount. A is the same as B. B is the same as C. So A and C weigh the same. So GJ is congruent to MK. Transitive property of congruence. Done. So notice that having some of these theorems makes our thinking and action more efficient. So now we have a conclusion, bam, we can go do it in the practical world. We didn't have to draw triangles and mess with this and do it all, make a longer theorem, because we knew that angles being congruent means the sides are congruent. We could do a whole lot of work in just one step. That's the power of abstractions. All right, good.